Hey folks, so to get the advanced level, these are a little trickier, so pay attention to see the techniques, okay? So in these ones, we're looking to see, it says identify corresponding sides and the scale factor. Figures may have other transformations applied to them and may have horizontal or vertical line, may not have horizontal or vertical lines. So you're gonna have to use corresponding distances in these cases. That's a little confusing. So let's start just doing what it tells us to do. It says, in this case, side FI corresponds with. So let's take a look at FI here. And you look over here, you say, all right, if this is, it looks like it's maybe rotated 90 degrees, and it looks like it's going to match up with this one here if I rotate it. I think it's going to be right here. So that's going to be the shortest side on this figure. So yeah, that would make sense. It corresponds with the shortest side over there. So FI goes this direction from sort of top to bottom here. So this is going to be called YZ. So that's in step one. So now that I have those two pairs of sides are corresponding, something I can do is try to figure out what is the ratio between these sides. Now, if they're on a diagonal, it's a little harder, but what you can do is draw a little triangle that goes up and over like that. And that's a 2 by 2 triangle right there. And I could do a little triangle here, and that's a 3 by 3. All right. So now I say, oh, those distances should also, remember, all distances in dilated figures are proportional, meaning they all share that same scale factor. Should always work. So we know that the image is the new one. This is new, and this is pre-image is the original. So we're going to use that same formula again. I'm going to say orig here. K equals new over original. So I could just do 3 over 2, and that should work out here. Right? And I could divide that if I wanted to. 3 divided by 2 is 1.5. So the image is 1.5 times as big. Now, what's cool about this is I don't actually have to have done these sides here. I could have picked another pair of corresponding sides. Let's say I pick, I'll do a new color here. Let's say I had done FG was corresponding, and I believe that's going to correspond right here to YX. Okay. Again, I can draw a little triangle, a right triangle here, and this one goes up. Let's see, over. There we go. And I can draw a right triangle here. So this one is 2. And this one, careful, count it carefully. 1, 2, 3, 4, 5, 6. That's 2 and 6. And this one is 3. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, these triangles are also have corresponding distances that are going to be using that same dilation constant. So I can use that same formula. For example, I can take the short side of the triangle here, like the 2, and the short side here, which is 3, and do again 3 over 2. There's the same ratio as I got before. I could have also taken the 9 and the 6, which would be 9 over 6. New distances over old. I simplify, divide by 3. On top and bottom, divide by 3. And my fraction simplifies down to, lo and behold, there it is, 3 over 2. So what we know now is that 3 over 2 is the same as 1.5, 1.5. So this image is dilated. It's 1.5 times, all the lengths are 1.5 times as big as the pre-image. I think that's pretty cool. All right, that's all there is to it. And we'll go back. Good luck with that.